This video is to help you learn how to name acids, both write the formulas and create the name for the group called acids. So what is an acid? An acid is just an ionic compound where the cation component is hydrogen. Okay. Simple as that. Hydrogen has a charge of +1, so the chemical formula includes however many hydrogens you need in order to balance out the anion's charge. So for example, if your anion had a charge of like -3, you would need H3 or 3 hydrogens. Now, because the anion component is what determines basically all the properties, since the hydrogen is the same throughout all of the compounds, the name is based on what the anion is. So there's 3 possibilities for the anion. It can be an anion for the periodic table, it can be an anion ending in -8, or an anion ending in -ite. If it's from the periodic table, which means it would end in -ide, you take the -ide away, you give a prefix of hydro, and you add the suffix of -ic. So if you're working with the chlorine anion, which would be chloride, take away -ide, and it becomes hydrochloric acid. If you're working with a polyatomic that has an 8, the 8 is removed and replaced with the suffix -ic. So if you're working with like chlorate, for example, that becomes chloric acid. And I can remember it because I ate something icky. It's an easy way to remember that 8 is replaced by -ic, because I ate something icky. If you have ites instead, chlorite, then the ite is replaced by -us, chlorous acid. The thing that you have to be able to do when going from a name to a formula is determine how many hydrogens that you have for the final formula. So you need to determine what the anion is from the name that's given, and then for the cation, it's you determine the number of hydrogens. The number of hydrogens just are there to balance out the overall charge of the compound. So if it's, again, a charge of -3, then you need 3 hydrogens. So let's do a couple examples so you see how this works. If we're working with one like nitric acid, for example, ic tells us that it's from the polyatomic 8, because 8 is replaced with ic. So this is nitrate, and nitrate has a chemical formula of NO3 - 1. So that is your anion component. And because it's an acid, you add as many hydrogens to the front as you need to balance out this charge. So since it's a -1 charge, you only need 1 hydrogen. Take away your charge because you never have a charge on the final compound, and that's nitric acid. Phosphorus acid, us, means that it used to be an ite. So this is phosphite. And you see that the name is a little different. It goes back. Sulfur and phosphorus both go back and add their R's back in when you make the acids, something you're just going to have to get used to. So this is phosphite. Phosphorite is PO3 - 3. The -3 means you need 3 hydrogens to balance out the -3, because that'll get you a +3, and then you get rid of your final charge. Sulfuric acid, ic, means it was 8, so this is sulfate. Again, you have your R back. Sulfate is SO4 - 2. To balance out that -2 charge, you need 2 hydrogens. Hydrofluoric acid, hydroic acid, means it was from the periodic table, or ide, which means this is fluoride. Fluoride is an F, it has a -1, so you need 1 hydrogen to balance it out. So with acids, the main thing you need to work on is determining what the anion component is given the changes in the endings. Once you get the chemical formula and the charge, you just add hydrogens to the front to neutralize the overall charge, and that's it.